Welcome to the Nestlé Engineering Automation Toolbox version 7. In this video, we will have a look to the generic VFD reverse type in details. So I propose to have first a look to the Automan modes. So from the faceplate that I have here on my InTouch applications, I have the automatic button. If I click on it, I can see the status that switched to auto on top, and the manual button with the manual status on top of the faceplate. Now if we look at the icon on the display for the operator, if I switch to auto, you can see that the M on top right disappears. If I go back to manual, I have a M that appears to indicate to the operator that the actuator is on manual mode. In the PLC, we have a ring that we need to look at for the Automan status. So you will see that this bit Automan will change, will be 1 when the automatic mode is selected, and will be set to 0 when the manual mode is selected. You can see as well that you can pilot the operator request from the PLC. If I toggle the operator request here, or if I toggle the manual request, you can see that I was switching the mode. If needed, you can as well, from the PLC, just latch the prog auto request to force the auto mode. And vice versa, you can latch the prog manual request to force the manual mode of the actuator. To start forward or reverse the motor or the VFD or stop it, we have some commands which are there. So manually, the operator, if I switch from my faceplate to manual mode, can go reverse, can go forward. Notice that only the status here is indicating that the motor is going forward or reverse. If I switch back to reverse. And we have as well a stop button. So on the PLC side, we have the 3 commands from the operator. So we have the oper start request forward, start request reverse, and last case for the stop, where either the request forward and the request reverse are set to 0. From the automatic point of view, there is a prog command forward, prog command reverse, and same, if both are 0, then we will send the stop command to the motor. So to demonstrate, let's switch to the automatic mode. I will toggle this command forward, and the motor is started. I will toggle again to 0, the motor is stopped. Can toggle to reverse, the motor is going reverse. This is true if there is no process interlock, no secure interlock. Those interlock will be subject of another video. For the state forward and reverse, there is a specific line of code on the PLC side. Here. So we have the line for the forward state, for the reverse state, and the off state, which is a combination of the command status forward for the forward state and the running feedback. For the reverse state, second line, it's a combination of the command status reverse and running feedback. And for the off state, it's a command status stop condition with the running feedback. From the faceplate, the operator can as well control manually the speed of the drives. So basically, from the faceplate, you can see first the current value of the speed, and it can change the command value for the speed. So basically, on the code for the details, the first rung, we have the scaling calculation from the raw value of the speed feedback. Below in the code, we have the calculation of the scaling for the CV raw value, the control value, which is there. So here is a rung for the CV raw value. So we have a couple of options here, or calculations first. So the first calculations, we look if the CVAU value coming from the operator or coming from the PID e-controller is between the boundaries for the mean speed and max speed. So here I will change, for example, my max speed to 100%. If I want to have my drive limited to 80%, I would have put here as max speed 80%. And in the case that my CVAU from my PID would be greater than my max speed, I will change slightly the calculations to have my speed limited to the max speed configuration here. The same for the minimum speed. You can set a minimum speed for your drive. So from an operator perspective, here I can set up the speed, for example, 85%. In my case of simulations, my PV is copying my 85%. I will show you later in this video the simulation capabilities. In terms of fault, the code provides some diagnostics. So first we have the thermal overload and the on switch on. So basically the thermal overload, the information expected on the PLC side is a 1, but this thermal overload is conditioned to the overload input that can come from a network or from a physical input. And depending on the type of drive that you use, you might need to reverse this information. So this is in case that you are not on simulation. Here I'm simulated. I will show you later on how to unlatch this bit. And prior to that, I want to show you the on switch on, which is the exactly same logic. So we expect to have an on switch on at 1, a status 1 in the PLC. So we condition the on switch on input with a reverse bit to get this information set to 1. So in terms of simulations, I will go down into the code. So here I have my simulation thermal overload in the rung 32. So basically right now I'm simulating, I'm forcing this thermal overload feedback. I will just toggle this bit and switch to digital input like for an OTS system. I forgot to latch this bit, and you can see that right now if I toggle this overload input signal for the thermal, that I will lose this thermal overload feedback and I will get the information from the faceplate. Then if the operator tries to start, it will get the fault. So then we have this button reset fault that goes and reset clearly the fault. The thermal fault is still there, active. So I will toggle again this overload input signal. And now I will do the on switch on input signal, Control T. And here you can see that I have the on switch on. The same if I try to manipulate manually the actuators, then I will get a fault. So the operator will have to reset the fault. The technician will have to have a look to the on switch on or to have it at the right position in case it was really not set correctly for the production, and then you can restart your motor. For the fail to start and fail to stop fault, I have added on my HMI a simulated running feedback. The line of code is here. So as you can see, we can either simulate the feedback from the command status forward or reverse, or to add an additional information that is coming out of this add-on instructions. So in this case, it will come from my HMI. So now if I go up to the fail to start, fail to stop informations here. So rung 14, I have my start transit fault, and rung 15, I have my stop transit fault. So in the case that I'm going forward and I do not check my running feedback box, then I get my fail to start information from the faceplate. This fail to start will disappear if you reset the fault. The same, in this case, I will go reverse and I will check my simulated running feedback. So in this time, it's okay. I have my started status. If I go to stop, but I do not uncheck this running feedback, so let's do. So I go to stop. I do not uncheck this feedback, and I will get my fail to stop. Same, it will stay. This condition will stay until we leave the running feedback. And then you can reset the fault. The last information available as output for these add-on instructions is regarding the speed, where we have a calculations once the variable frequency drive is started. We have the at speed state, as well as deviation alarm that you can configure if you are out of the range for the mean speed or the max speed. That's it for the variable frequency drive reverse and for motors in general. Thank you.